vectors. Here we go. So starting at the very beginning, okay, if a quantity only has magnitude, that's called a scalar. Oh my gosh, you remember. Scalar. Yep. Yeah, dude. Quantities that have both magnitude and direction is a vector. Okay. There's just so much information on vectors. I kind of just threw it all at once for you, but hopefully it looks a bit familiar. Yay. When you draw a vector, the length represents the magnitude, and then the arrowhead shows the direction of travel, right? And then, so for example, you have the vector OA. The O is the initial point and A is the direction and where it goes. Usually, since you can write the vector with the initial point and the terminal point with the arrow, or you could just use a simple letter. I like to use the arrow notation, but if you use any notation that I know is a vector, not just like the letter A, don't just use the letter A. Show me by some point that's a vector, so that way when you show me magnitude, it doesn't look like the absolute value of a number, right? It looks like the magnitude of a vector. Okay, here we go. So, okay, so well, we'll get to more vectors. Here we go. All right, component form of vector, right? Either this way, x, y, or you can also see it like this, x, y. Which way did Meta show you? Both. Excellent. All right, so you have your x step and your horizontal step, which means you have a right triangle, which means there's some geometry that you can do. Sweet. Okay. Yeah, when you're adding vectors, you basically just add the components. So you add the x's together and you add the y's together. And then that would be adding two vectors together. Sweet? Okay. Let me know if I'm going too fast. Oh, sorry. Go back. Okay, so the negative of a vector. Good. Okay, so negative vector would just be the negative of the two components. Notice the only thing that changes is like the direction of the vector. It still has the same like magnitude, still has the same slope-ish, but the direction changes. Okay? The zero vector is a very useful vector because it's you're just adding 0, 0 to something. So you got the identity property, you got the inverse property going on with vectors. Okay? Okay. Subtraction is the same thing as adding the negative of the vector. So basically it's just subtraction. So I mean, the whole point of this is it's all about components. You just combine the x components, find the y components. Okay. Scalars. Scalar multiplication. You just multiply the components by whatever the scalar is. So you'll have a number on the outside. Just multiply them all by 2. Okay. Yay. Okay. I think that's everything in that one. All right. Ooh. Okay. The position vector between two vectors. All right. Here we go. I think this is also called the displacement vector. Maybe not. Maybe not. Here we go. Did I get it on that one? Negative vectors. Yeah. We'll get to that one. Okay, so if you want to find, let's say you have vector A and you have vector B. If you want to find the vector, so vector A is like this from the origin, like this, right? And then vector B, let me change the pen to a different color. Vector B would be like this, sorry. So to find vector AB, all you do is subtract the B from the A. So it's backwards. Yeah? Okay. And that's where this thing came from. Right? I'm pretty sure this is also called the displacement vector. Yeah. Okay. Yeah. Midpoint formula for a vector, right, is you just take half of the A plus B. I'm not sure if we can get to any questions of that, but know that that formula is there too. I'm pretty sure this is half of vector A plus vector b, because, I mean, I'm going to put, when I write it, I'm going to put the arrow on top just so you know it's not just the coordinates, it's vector. All right, here we go. So you said you did three-dimensional vectors too? Same rules apply with three-dimensional vectors. Yeah, you have vector addition, vector subtraction, and scalar multiplication. Some of these properties with vectors should look familiar because they're the same properties in algebra. You got commutative, associative, identity, inverse, yeah. And again, it just repeats for this part that if you want to find AB, then it's B minus A, and then BA is A minus B for the displacement vector. All look familiar? Is this how far she got?
Well, we did more.
You did more. Did more. Excellent. All right. Well, before we do some problems, let's talk about a unit vector. IJK, did you use all those things? Okay. So IJK basically are your x-axis, your y-axis, and your z-axis. So like in the basic xy axis, I would be like 1, 0 for x, and then nothing y, and then nothing x, and then y, right? So these are all vectors right here, and then your k and l would just be the scalars for it. So this looks familiar. Okay. P.S. If she showed you a trick, please share and remind everybody, because I know Meta's been doing it forever, so she knows stuff. Yeah. Like IJK, something like that.
Like IJK.
IJ. And when you did the dot product, that's what you did, right? Okay, so when we get to dot product, remind me of that one. That's going to be next class. Basic addition, P plus P would be 4 over. Oh, wait, I keep, sorry. No. Yeah, me too. It's not a fraction. All right, there you go. 10. Okay, so 4 and? Oh yeah, -6. I thought it was 2. Okay, -6. Good. And then 2 plus 3. Nice. Good times? Just adding the components together. Okay. Here we go. Show that there's a number s such that this plus this equals r. Have you done something like that? Yep. Basic IB question. What's up? Yeah. Okay, so she didn't start out with anything this simple? Okay. Sounds good. All right. So just replacing the vectors with their components. I got 2 over -3 plus the scalar s, 1, 2 equals 5, 3. Okay. So taking the first, the x components, you have 2 plus s equals 5, so s is equal to 3. True? Okay. And the bottom component's -3 plus 2s is equal to 3. Add a 3, 2s is equal to 6, so s is 3. Since s is 3 on both sides, then the equation matches that b plus 3q is equal to r. And let me go ahead and put vector things on that, or vector notation. Too easy. Okay. The assignments in the book obviously are going to be this crazy. They have the same like basic principle, but they're going to be more of the IB level. But this just gives you like just refreshes you on those rules. Yay? Okay. So you're welcome to start on your assignment, and I will be around for questions.